So even though you see a half a circle on the screen, it's a full circle. And even though it's a circle on a graph, remember this is the x-axis and this is the y-axis. So what I want you to realize is that even though we have degrees on a circle, these coordinates over here are to be treated like x and y. So if you remember that this is x and this is y, actually, let me just use a different color. Let's use blue. So this is x, comma, y. So what you have to start thinking about is the first value x corresponds to cosine, and the second value y corresponds to sine. So these are degrees, but the pi over 6, so for instance, 30 degrees is pi over 6. That is just the measurement or the degree in radians. Okay. All right, and do I have a highlighter? Is that a highlighter? No, that's eraser. Spotlight. I'm gonna try. What does that do? I don't know. Okay. So also take notice to 0 degrees to 90 degrees. And then to 180 degrees, because they're all special. Why are they special? I'm going to clear all the drawings. So why are they special? Because at 0 degrees, notice what x is equal to and what y is equal to. Then at 90 degrees, let me circle 0 degrees as well. And then at 90 degrees, what is x, what is y? So x is 0 and y is 1. And then at 180 degrees, what is x? X is -1 and y is 0. Okay, so I want you to think to yourself, imagine what it is at 270 degrees. And 0 and 360 are the same. So I don't see it on there right now, but when we go one full revolution, we have 360 degrees, right? So 0 and 360 are similar. They're not the same value. They're not exactly the same value, but they start and they I don't want to say they start and stop, because a start ends at a stop, right? But so we start at 0, then we end at 360. But the value in radians for 360 is equal to 2 pi. Okay, that's my 2 pi. It's I'm writing with a mouse, so you know. Okay, so the reason why I point those out is because you kind of have to memorize them. So if I say, what is the cosine of 0, you should quickly tell me 1. And the way I remembered it was I remembered one, but not the other. So if you can remember all of the values all the way around the circle for cosine, sine has got to be the other number, right? So if I say, what's the cosine of 0? And you say it's 1, then you don't have to memorize that sine is 0 because you know that sine is the y value. So if cosine is 1, that means that sine is the 0. Then when you go to 90 degrees, and I say, what's the cosine of 90? I'm sorry, what's the, cosine of 90 degrees? You would say, oh, it's 0. So if you remember that, then if you remember cosine, because this is the way I always remembered it. If cosine of 0 is 1, then when I get to the other side of the x-axis, the only thing that x does is change to negative, right? So if I'm in the first quadrant, x and y are both positive, and when I get to the second quadrant, x is negative, but y is positive, but it's still 0 for 180, right? So that's how you kind of train your brain to think about it like that. And then it helps you memorize it. And it's just a 1 and a 0, so it's not hard to memorize, really. So for me, I like to memorize the first coordinate. It's just easier to remember the x value than to remember the y value, because the y value moves, it like changes in my mind, like where is it exactly? But if you kind of are the kind of person who thinks backwards, you can also say, okay, well, what is the sine of 0? It's 0. Well, what's the sine of 90 degrees? It's 1. What's the sine of 180 degrees? It's 0. And they just flip-flop back and forth. Just the only thing is the sign changes. So if I said, what is the cosine of 270? What would you say? Say it to yourself. What do you think it is? So, let me see if I can change. I'm going to clear all of this. And I'm going to change the thickness of this. Oh, I can change it to highlighter here. Okay. Okay, so I'm going on the x-axis here, right? The x value is there. The x value is there, right? So if I go straight down, what do you think would change with the y value? What's y going to be down here at 270? What do you think? Did anybody say it? Did somebody say it quietly? So look at the difference between, if I move this, let me see. If I move this, will it stay highlighted on there? No. That's asking for a little too much. Okay. So let me say that again. So x-axis, right? Straight across the x-axis. So cosine of 0 is going to be 1 for x, right? Cosine is x. And then on the other side, if I do half the circle at 180 degrees, what is cosine? Say it. What's x over here? I got it point. I got the arrow pointed to it. -1. So if sine, right, up here is sine of 90 degrees is my one number, what do you think it's going to be when I go down here? What do you think? Use the same logic. -1. There you go. Right? I did that on purpose because, again, a lot of things that I do is because of the professors that I had did not tell me this. I had to figure it out on my own. So when I took trigonometry, I just memorized, 1 0 0 1 -1 0 0 -1. I didn't connect a lot of the things that I should have connected. All right, so okay. So let's start a new document. Let's just save it. All right, so if you want to know how you go from degrees to radians, let's say you want to go from 45 degrees to radians, I divided by 180. And then if you want to go from the radian measure, let's say pi divided by 2 or pi over 2, you just flip the pi over 180, 180 divided by pi. And that gives you your degrees.